So I can see some people there just sharing the PDF for the engineering desktop, which is a good thing. So I sent out an email, I think it was yesterday, just outlining that we're going to be using some of the analysis features and some of the simulation features that unfortunately you don't get as part of the student copy of Creo. So the workaround for that is for people to log in to the Hallam systems and use the virtual desktop or the remote desktop, which you can hopefully see on my screen. So this is my login route when I kind of boot up my remote desktop app that I've had to download. And then I double click on engineering desktop there, and it kind of goes away and loads up. And then I get dropped into a just looks like a normal Windows environment here. You can tell that you're on the virtual desktop because you get this kind of readout at the top right, just kind of outlining some of the info about your connection and the machine that you're connected to. So when you've actually done all that, hopefully you'll be able to see that Creo Parametric, which is what we are using, it's none of the other kind of sub programs that come with Creo. It's Creo Parametric is the one that we are doing all our work in. That's the one that you want to load up. And then when you do get to that point and you do load it up, it should just appear kind of largely, if not identical, similar to the student version that you may have been using up to this point. So I think there's a subtle difference here in that these Hallam installed copies of Creo have had their kind of interface colors customized slightly. So you get this kind of blue background color. If you really want to switch that to the kind of default color scheme that you've probably been using if you're using your student copy up to this point, then that's pretty easy. When you get in there, you just go to File menu, down to Options, and then I think it's under System Appearance. Yeah, here we go. And if you just change the theme to one of the other themes and then back to default, and then click on OK, it should then be using the default color scheme that you're probably used to when you do the student installation. Yeah, unfortunately, we still don't have the attendance code. I keep raising it, and nobody seems to get back to me with a login code to let me generate them. But yeah, I'll keep asking in the hope that IT will actually get back to me and sort that problem out. I suspect it's because I'm not logging in using some hardware provided by Hallam. So they haven't provided me with off-site hardware, so laptops or anything. So I'm logging in through my own system. So I think the code generation system's got some sort of issue with that. So unfortunately, we still don't have the codes. So I'm sort of talking a little bit at the top of the session here, just to give people a chance if they need to kind of download the remote desktop app, which shouldn't take that long really, and just sort of read through those PDFs that are provided on the ShoeSpace website, just on how you get that virtual desktop running. So what I'll do is I'll keep talking about the content that we're going to actually do this week. So I'm going to minimize my virtual desktop now, and I'll just browse onto the learning content for the tutorials. And if you scroll down, I believe we're on week 7 now, so we're in this area. So we're going to be looking at things to do with analysis, certain different types of studies that we can do on our designs, sensitivity analysis, feasibility analysis, and ultimately optimization. And to give you a bit of background about what these tools in Creo allow you to do, if we take the 3 sort of main ones, we've got sensitivity, optimization, and feasibility. So sensitivity analysis allows you to investigate how changing dimensions on a design will affect some kind of monitored value. So some of the examples that we're going to look at, we're going to monitor, say, the volume of liquid that a cup can hold. And then we're going to modify that cup to see how changing the dimensions actually has an effect on that. And then in some of the later studies, we're going to look at a simple hand water pump that you may get on sort of an old style well or something. So if you dig a borehole somewhere and you want to pump water up, you get sort of a simple lever set up with a plunger, and you kind of move it with your hand. And we're going to use these tools to investigate how changing the pivot point affects the volume of water that the pump can actually deliver. So that's sensitivity analysis. It's looking at how sensitive a measured value or a measured quantity is to change in your design. And these changes that we're going to instigate are going to be governed by changing dimensions that created that design. So that's sensitivity analysis. How sensitive is a measured value to changes in the design? Then we get optimization studies. Optimization studies basically allow you to give Creo access to some of the dimensions in your design and give it a goal that it's trying to hit. So again, in our case, we're going to use this hand pump example, and we're going to try and maximize the amount of water that it pumps on each stroke. And then we're going to hand over some of the dimensions that are governing the shape and size of the pump to Creo, and it's going to go away and modify that design and come up with the optimal setup to actually reach that goal of maximum amount of water pumped. And then the last kind of type of study that we're going to look at is known as a feasibility study. And this is similar to the optimization, but it doesn't really have a goal as such. It's just a question that you pose that is basically in the form of a yes, no, or a pass or doesn't pass sort of question. As in, the design that we're going to look at is for a crankshaft out of an engine. And we're going to ask the system, by varying this dimension, we're going to give it access to one of the dimensions in the design. Can the center of gravity of this crankshaft be centered around its rotational axis, which is obviously important for a crankshaft, because if it's not balanced, if its center of gravity isn't coincident with its rotational axis, then it sort of it ends up sort of wobbling and potentially sort of rattling the engine that it's in to pieces. So that's so feasibility studies are kind of yes no questions where the system will go away and analyze whether something can be done or not. Optimization studies sort of take control of a design or partial control of the design away from you and give it to Creo, and it will optimize towards some kind of goal. And then sensitivity analyses allow you, the user, to just look at the effect of varying certain dimensions on your model against a set of monitored values, if you like, or calculated values. So yeah, that's kind of what we're going to do this week. We're going to look at those three areas. In addition to that, we're going to be utilizing some of the stuff that we know about parameters and relations, which we kind of done already in a previous tutorial. So we kind of covered a little bit about relations and parameters. So in case you're having trouble remembering, relations tend to encompass things that you could call little formulas that link values to each other. So you can calculate new values from existing values within a part. That tends to be your relations. And then parameters are any kind of text or numerical value that you want to attach to a design or to a part. So we're going to use those a little bit as well as we go through this. So hopefully that'll have given people kind of enough time to just get the virtual desktop up and running. So we'll drop into the first example that we're going to look at. So we're going to start on this PDF, and that's going to be kind of our first little piece of the tutorial. And then everything else is contained within that week 7 zip file. So I don't know whether you want to download that week 7 zip now, and then obviously you'll have to unzip that into a folder. And then when we start on that section of the tutorial, you'll tell Creo that you want to set your working directory inside that folder. So I think I've already done all that. I'll just double check. So I'm going to set my working directory. I think for the time being, I'll just work within the folder which is called week 7. So I'm going to generate a new part, and it's going to essentially be a very simple cup shape. But I'm not going to load that in, so I don't need to browse down into this tutorial parts folder just yet. So I'm just going to stay at the top level in my week 7 folder, call that my working directory for the time being, and then I'm going to create a new part. And the part that I'm ultimately going to quickly model up is inside this calculate internal volume of a cup PDF. And it's essentially that shape there. So I'm going to model that up now quickly, just using an extrude initially. So it'll be a circular sketch extruded to a depth, a round feature that's been placed on the bottom edge of that, and then a shell feature that's shelled out all that material inside. Now from this screenshot, you've only got the major dimensions here. So you've got the 200 height, the 200 diameter of that initial sketch, and then the round, I'll come up with a reasonable value as we go through. So those values aren't super critical for this example. This is more just helping us to have something to actually create our analysis features on. So we're going to create some analysis features later on. So yeah, I'm going to model that up. I'll pull that PDF across onto my second screen just so I can keep bringing it back for reference. So I'm going to create a new file. I'd probably call it cup, just in case I want to save it and bring it back in again. Seems sensible. Millimeters, newtons, seconds is what we're going to use. So just the same part template that we always use. And then I'm very quickly going to create an extrude on the top plane. So I'm going to click on the top plane, and then of those quick access icons that pop up, you can see the extrude ones actually in the middle line there, just the second one along. So circle tool, lock the center point of the circle onto the origin, drag it out, hit escape because I don't want to sketch a second circle, I only want one of them, and then just double click and edit that value to 200. So that's the sketch finished. So we can OK the sketch. So I'll click on the green tick at the top right to OK the sketch. And then I'm getting a preview of the extrude. So I'll just rotate around just so I can check that it's going in the direction that I want it to. Yes, it is. And I want to set that to 200. So you can see mine's already set to 200, but you might want to double click on that value and just set it to 200. And I want it essentially to go what I'm considering as up in my part environment. So I want it to travel away from the top plane in the direction that you see in there. So the direction of the Y leg of my base coordinate system there. So I'll OK that. Then I want to apply this round feature to the bottom edge. So that's the edge that's sat on the top plane there. So I'll click on the edge, and then again the quick access toolbar offers me the round feature icon as a potential feature to apply to what I've clicked on. So click on round, and I think I'll set this to about 25 millimeters radius. So yeah, so I'll double click on there, set that to 25. As I say, this isn't super critical, the actual dimensions in this example. This is more just to give us some geometry to perform some of the analysis features that we're going to be learning how to use. But yeah, if you want to follow along with me, that round is 25. And then the final thing that we're going to do is shell out the inside of this part. And again, there's a quick way of doing this. If I click on that top face, which is the face that I want to get rid of with the shell command, the shell icon is one of the quick access icons that the system offers to me. So it's that icon there, shell. So again, with all these, you can go up to the toolbar at the top and pre-select shell and then set the options. But it's a lot more efficient working by not moving your mouse pointer away from the model if at all possible. So yeah, utilize those quick access icons that pop up if possible. And then I think we'll set the wall thickness to 5mm. Again, not super critical. This is just something to hang our tutorial on. The actual dimensions that I'm putting in here are not that critical. So I'll click on OK, and that's essentially my cup shape. Now I could give it a handle, but for this tutorial, or this little piece of the tutorial that we're doing now, the task is to get the system to calculate the maximum volume of liquid that this container could hold. And having a handle attached to the side makes no difference to that whatsoever. So in the spirit of kind of speeding up these tutorials so that we get through as much as possible, I haven't put the handle on the side, but you could model that in. So what we're going to do now, there's a process to this sort of next step. Ultimately, what we want to know is what is the volume of the kind of internal, the internal of this cup. Now, we can't just click on the inside of the cup because there's nothing there. Where the liquid would be, there's not actually a feature there. It's empty space. So we need to come at this in a slightly different way. And the way that we're going to come at it is we're going to calculate the volume, or we're going to let the system tell us the volume of the unshelled shape. So you can see what I did there was I temporarily suppressed the shell feature. And the way that I did that was I grabbed this green bar, which is kind of the place in the feature tree or in the model tree where I'm about to insert a new feature. So I left-clicked on that and held, and then I'm able to drag it back to a previous time in the model. So I'm able to drag it, for example, above the shell feature and then let go. And what that does is it returns to a previous point in the modeling process. So you can see the shell is still there, but it's grayed out, and its effect in the graphics window has disappeared. So this has gone back to a solid block of material. Now what I can do now is I can have the system tell me what the volume of that solid block is. And it will keep a track of that. If I make any changes to the dimensions of this cup, it will continually update that value. So we're halfway there. So if we can get the system to tell us the volume of the unshelled part, which is this volume, and then we can get the system to tell us the volume of the shelled part. So when I say the volume, I don't mean the internal space. I mean the actual volume of that wall thickness. What is the volume of that? Then I can use relations to minus that second volume away from the first one. And what that should leave us with is that volume of empty space inside. So this is a combination of a new skill that we've not used before, which is analysis features, which is what we're about to create, and relations, which we kind of understand what relations allow you to do. They allow you to relate values to each other or enter simple formulas to calculate new values from existing values. So yeah, that's kind of the workflow that we're going to do. So the first thing that we need to do is we need to create an analysis feature before the shell. So I'm going to click and drag that bar again up above the shell. So the shell gets temporarily suppressed. And then because these are all analysis features, they're all stored within the analysis tab at the top there. So we don't want to be in the model tab. We want to be in the analysis tab. And it's a type of measurement. So I'm going to click on this little drop down. Sorry, no code. I'm just keeping an eye on the chat window here, and someone's just asked for the attendance code again. So yeah, click on the drop down. There's various quantities that we can measure or we can create analysis features for. We've already said volume is the one that we're interested in. So click on volume. And then what we get is a little kind of annotation attached to the part, just informing us what the volume is in our selected units. So that's all very useful. And if that's all you need, then you can just kind of take a note of that and then close this measurement feature down or this measurement tool down. But that doesn't keep track of that volume. What we want to do is we want to create a permanent feature in the feature tree, which is keeping track of what that volume is. And it keeps track of it even when we make changes to the actual design itself. So I'm going to initiate that again. So measure, volume, and then I want to kind of browse inside here and see a bit more detail in this measurement or measure volume dialog that's appeared, this window. So I'm going to click on the plus sign there. And then you can see it's referencing the cup, which is the part that it's measuring the volume of. I can open up the results section there, and it's showing me the volume again and the units that it's measuring in. But what I want to do is I want to click on this little disk icon at the top, and I want to define a new feature. So I want to make a feature that appears in the feature tree or the model tree over here and stays there permanently. And it's there to keep track of what the volume of this unshelled shape is. So we're going to give this a specific name. So I'm going to bring the PDF back in again. So what name are we going to give it? We're going to call this one solid volume because it's the volume of the solid block of material before we shell it out. So solid volume is what we want to call this one. So we'll overtype there. Solid volume. I don't need the 1 at the end. So click on OK. And then hopefully you'll have noticed over on the right, left-hand side there in the model tree, a feature has appeared with the icon that designates it as an analysis feature, which is that little kind of ruler and X and a little dashed line called solid volume. So now when we close this measurement window, that should stay resident, or it should be permanent in the model tree. Could I do that again? Yes, I will. I'll do it again. So I'm just going to delete that feature. So now it's gone. So we go into the measurement drop-down menu, just underneath that ruler icon. We're going to measure the volume of the current model here. And then you can browse into here and see all these extra details, but you don't need to. Really, you just need to click on that disk icon. And there's two options here. I can either save this or I can make it a feature in the list of features in the model tree here. So I want to make a feature of this and have it sit in the model tree at this point, just under the round feature. And then more than that, I want to be able to easily identify it later on. So when I start typing relations into the relations entry box, I want to be able to identify this measurement feature or this volume as the one which is the unshelled cup. So before I shelled it out. So in order to indicate that, I've decided to call it solid volume. And then the one that I'm going to do with the shelled cup, I'm going to call shelled volume or something like that, just so I can tell them apart from each other. So name it as solid volume, click on OK, and it should appear over there on the left with the name that we've just given it. So solid volume, yeah. So that sorted that out for that person. Then I don't need the measurement tool anymore, not right at the moment anyway. So I'm going to click on the little X there just to close that down. Then what I'm going to do is I'm going to roll this green bar back to the kind of present, if you like. So I'm going to pull it down underneath the shell feature. So the shell feature gets reinstated. And then I'm going to perform all those operations again, because I want to know the volume of the shelled cup as well. Because, as I say, ultimately, the solid volume minus the shelled volume will give me that empty space inside that is intended to be filled with liquid. So it'll give me the volume of liquid that the cup can hold. So I'm going to do the same thing again. I'm still in the analysis tab at the top there. I'm still going to click on the measure kind of drop down menu. I still want to measure a volume, but it's going to be the volume of the shell now. I'll click on the disk icon to allow me to create a feature from this volume. And again, I'll give it a descriptive name. So maybe shelled volume, like that. And then press enter. And then you can see that then gets put in the model tree as well. So I don't need that volume window anymore, so I can close that down again just by clicking on the X. So now I've got two volumes that are being monitored, but we need to understand a little bit more about how these features are keeping track of those two volumes. So we'll take a little bit of time just to kind of understand that now. And what I'm going to do, I'm going to go into the Tools menu, or the Tools tab at the top there, because that's where the parameters and relations buttons are. So these are the two that we've used before in a previous tutorial. And what I'm going to do, I'm going to click on the parameters one, because again, we should be reasonably familiar with this. So within each part, when we create a brand new part, the system supplies us with two pre-existing parameters inside those parts, which again, we kind of ran through this in the parameters tutorial. One of them is named description, which is kind of supposed to be your sort of plain English description of what the part is. So you would normally type something in there to describe the part. And then the second one is modeled by, which is normally intended for someone to put their initials in, or maybe their first initial and surname. So yeah, you get those in all new parts that you create. You get two part level parameters. So you can see they're stored at the top level of this part. But what we've just done is we've created two features there, two volume features that have a number stored within them, but it's not stored up at the part level. It's stored down at the feature level. So we're going to browse inside these features now, and we're going to see that each one of these features that we've just created has a single parameter stored inside it, and that parameter keeps track of those two volumes. So what we have to do, we have to tell the system we're not going to look at the part level, we're going to look at feature level. So click on that drop down that currently says part, just under the word looking, and we're going to look inside a feature. And then we're going to click on one of these features. So I'll click on the solid volume, and you can see within the feature named solid volume, there's a parameter that's just named volume, and it's keeping track of the volume of the unshelled cup. So there it is currently. So that's the measurement that it's essentially taking of the unshelled shape, if you like. So we can do the same thing. We'll click to select a different feature. So I'm going to click on this little arrow at the end here, and that's going to wait for me to click on a different feature, or the same one if I just wanted to repeat what I'd done. So I'm going to click on shelled volume this time. And again, within the feature named shelled volume, there's a parameter called volume, and that's keeping track of the volume of this thin-walled cup shape that I've created. So those two volumes are being monitored by the system now. But it's important for us to understand it's a parameter. That's how the system is storing that value. It's storing it as a parameter, which is stored within each one of these features that we've created. So that's going to become quite important in a sec when we start to create the relations. So the last little thing that I'm going to do before we move on to the next section is I'm going to create my own parameter. So if you shut down the parameters window like I just did there, you have to go back into the Tools tab, click on parameters to get it open again. I'm going to create a new parameter up at the part level, up at the top level. And I'm going to call it, so the way that you create a new parameter is click on that little plus icon at the bottom of the window there. I'm going to call it internal vol for internal volume. And when I create my relation or my little calculation, which is going to be the volume that's stored inside solid volume minus the volume that's stored inside shelled volume, I'm going to make them equal internal volume. So that number, which is currently 0, will get a calculated value entered in it. And that calculated value will be the volume that's stored in there minus the volume that's stored in there. So that's essentially what we're aiming for. But I've created this parameter ready for that kind of input that I'm going to create next. So I'll click on OK. So everything's set up. So now we're going to move on to the kind of next bit of the PDF. So let's go through the bits that we've done. We created that analysis feature to monitor the solid volume. We saw that it was resident in the model tree there. We created a second one. We called it shelled volume. Yep. Now we're going to drop back into the analysis tab, and we're going to create an analysis feature to do the little setup of our relation between how our final volume, or I've forgotten, internal volume is calculated. So we will need to go back into the analysis tab, click on analysis. So back into the analysis tab, click on analysis, and we're going to do some setup here. So the type of analysis that we're going to create is going to be a relation. So I've already kind of said we're going to calculate this new value from these two existing values, and we're going to use relations to actually do that. So click on relation is the first one. We'll probably give it a relevant name. So this is going to be the internal volume of things. So I'll enter that there. And then this regen request thing is basically when I make changes to my design, do I want this to auto update? So we'll leave that set as always. That's fine for us. And then all we have to do, so we've done kind of the setup there, we have to work down this list. So the name, it says changing, that's because I'm able to type something in there at the moment. So I was changing the name of this analysis feature. I'm now done with that, so I'm going to click on type. Type is relation, I've already set that, so I don't need to change anything there. Regen request, I want it on always. Again, we've set that already. Definition. So if I click on definition, and then I'm going to double click, and it drops me into the relations window, which again, we kind of played around with relations a little bit when we were doing the parameters and relations tutorial. Please repeat the analysis step. I can. So give me a sec. I'll just quit out of there. So we want to click on analysis, which is the first icon at the kind of top left of the analysis tab there. Click on analysis, and we're going to tell the system that we're going to create a relation type analysis. We're going to give this analysis a name. So I'm going to call it internal volume. And don't forget, you have to use that underscore between words. You can't put spaces between words in Creo. So it's a relation type. We always want it to regen. So the first kind of three things that we have to define here, we've done. We've changed the name. We've defined the type of analysis that we want to create. It's going to be a relation. We're going to leave the regen request on its default setting, which is always. So the one thing that we haven't done is that we haven't actually defined the relation itself. We haven't actually told the system what we want this relation to calculate. So that's the bottom one in the list here. So you just kind of work from the top to the bottom. And in order to define what this relation is going to be, you double click on definition. So double click, and it drops you into the relation window. So again, this is kind of revising what we did when we were covering relations, which is you can type formulas in here. You can type formulas that will link one value to other values. And that's essentially what we're going to do. But rather than try and remember the actual names of things that we've created, what we can do is we can use this icon here, which is, it allows us to browse through the part and through the features that we've already created and see any parameters that are stored within the part or within certain features within the part. So it takes the onus off us, the user, having to remember the exact words and the exact location of every parameter that we want to enter here. We can just browse through it in a more sort of graphical, easy way. So click on that icon, insert parameter, name from list, and the equation that we're going to write here essentially is going to say the internal volume equals the solid volume minus the shelled volume. So that's kind of the equation that we want to create. So the first thing that we want to put in here is the internal volume. And we created that parameter within the part itself. We didn't file it away within a feature anywhere. We just created it right up the top at the part level, not down in a specific feature. And that's why it's listed here, because it's looking in the part itself. Which part is it looking in? It's looking in the part that we've named cup. So that's the name that we gave our part initially. And you can see we've got those two parameters that are provided by the system in every new part. But we've also got the one that we created called internal volume. So I'm going to click on that once and then click on insert selected. And there it is. So then I'm going to enter an equal sign and I'm going to do kind of a similar operation again. So I'm going to insert another parameter. So I want to click on those two kind of square brackets. But this time, I want a value that's stored within a feature. It's not up at the part level, which is kind of the top level. It's stored down within one of these features. So I want to change this from looking in the part to looking inside a specific feature. And then it's waiting for me to click on a specific feature. And if you look down at the bottom left there in the sort of dialogue, whenever it's trying to ask us for some kind of input, it will list here what it's waiting for. So it's saying select feature to access user-defined parameters. So it's that solid volume that we want to reference first. And then again, within that solid volume feature, so the feature that we've named solid volume, there is a parameter called volume, and you can see it now there. So there's only one parameter in there, so we don't have to select anything. It's just pre-selected the only parameter that's stored in there. So then we want to click on insert collected or insert selected again. And to understand the kind of syntax of what it's entered there into our relations window, it's entered the word volume because the parameter inside there is called volume. But then it needs some kind of method of identifying which feature that parameter has come from. Because we know there's also a parameter called volume that's stored in that feature as well. So they both have the same name, those parameters. So this last little bit here, this colon and FID 108, so that's, you've got to put the colon in there because that kind of volume is the name of the parameter, and then the location of that parameter is in a feature, so that accounts for the F there. ID as in identification, so feature identification, and then all the features have an internal number that the system refers to them by. So that one's been numbered 108. So it's saying volume parameter at feature 108. So that's why it's entered that syntax. And this is why I say it's better to do it this way. You as the user could memorize that quite easily in this case, but it's a lot easier to let the system find the actual syntax of each parameter that you need, rather than trying to remember them yourself and trying to type them in. That's what this option's for, so that you don't have to do that. Anyway, back to what we're trying to achieve. So we want to take that volume and we want to minus the volume of the shelled cup. So I'm going to put a minus sign now. And then we're going to do the whole thing again. So I'm going to click on the parameter kind of double brackets again. And again, this next volume or this next value is stored within a feature. It's not stored up at the top level, up at the part level. So I'm going to say look inside a feature. Which feature this time? The shelled volume this time. And again, it's only got a single parameter that's stored in there. It's only got volume, so I don't have to click on it. It's already been clicked on. I just have to click on insert. And that should be it. So it's going to calculate the value of this parameter by taking the value of that parameter and minusing the value of that parameter from it. So we can click on OK. And then click on the green tick there. And then essentially, we trust that the system has actually done what we require of it, but we can kind of check on that. So it appears to have created a new analysis feature, and it's named it Analysis 1. It's named it Analysis 1 because I forgot to rename it again. So if I wanted to rename it, I could go in there and edit definition and do that. But essentially, this should be called something like internal volume, or liquid volume would probably be a reasonable name. But anyway, we're assuming there's a parameter inside there. So let's have a little look. Let's go into the tools menu, parameters, feature, click on this thing. Aha, there isn't. And there's a reason for that, because the relation that we created is spitting out the sum, or the calculation that it's doing within that sum. It's delivering it up to the part level, and it's putting it in that parameter because that's what we told it to do. So that feature there, called Analysis 1, supplies its calculated value into that parameter there that we created to store that value. So that one is stored right up at the part level. So the purpose of all of this is to allow us to understand some of the tutorials that we're about to do. And that's because those tutorials come from the Creo sort of manufacturer's tutorial booklet. And what they do is they supply you with pre-made examples that you just practice your skills on. But what occurred to me when I read through them the first time was that they assume that you know how a lot of the setup has been done with these pre-made examples, and we didn't know that. So this is just kind of illustrating how the PTC organization that's created Creo have actually set up all the subsequent examples that we're about to do. So yeah, that's kind of all we're going to do with that. What you could do is just one final little step is you could take a quick note of what that figure is reading. So rather than trying to remember it, I would probably do a screen snip just as a little quick reference of what that currently reads. And then I might make a change to the cup and just check that it does actually update. So to make a wide-ranging change to this cup shape, I would go all the way back to the top of my model tree and maybe change the size in some way of that extrude. So if I click on that first extrude, one way to edit it quickly, rather than dropping into edit definition, which is a valid way of changing it, and a more detailed way of changing it. If I just quickly want to change one of the dimensions that was setting up that, I can click on that icon that says D1. And what that kind of does is shows me the major dimensions that are governing that extrude. So let's say I want a much wider cup. So I'll double click on this 200 and go up to 300. Press enter, and then it updates the design like that. So I would expect now the internal volume to be much higher. So I'm going to just investigate that now. I'm going to go into tools, go into parameters. Yeah, just from immediate inspection, it has gone much higher. So it starts with a 12.8, and it was sort of in the 5.4 region. So you can see from that screen clip that it is actually updating. So that was just a final check, just to check that I haven't somehow come out with a static value. It is actually monitoring a value that can change depending on how the design changes. So yes, someone was asking something. That person that was asking about the analysis step, did you kind of resolve that problem? Is that okay now? Can we move on to the next section of the tutorial? I'll just give him a second to answer. So essentially, that's kind of a little prelude, that bit of the tutorial, to what we're going to do next. So you can save that if you want to. I think I will. I'll leave it open in the background in case we have to refer back to it. But I'm going to move on to some of the tutorials which are inside that zip file now. So hopefully you've had chance to unzip that zip file. And when you do, you should end up with a folder called Week 7 or WK7. And then within that folder, there are various PDF files. And then there should be a subfolder called Tut Parts, so tutorial parts. And then within that, there's various folders that correspond with those PDFs. So we're just going to work down them from the smallest number to the highest. So we're going to start with that number 3, hand pump sensitivity. So that's the one that we're going to tackle first. So I'm going to get that PDF open on my screen. So here it is. And then I'll scroll back to the top of it. And essentially, the assembly that it's asking you to load in there. So there's a little kind of preamble. There's a description of the problem that we're about to face. But essentially what it asks you to do is load in this pre-made assembly file, which is named hand pump ASM. And that is found in the corresponding folder to this PDF. So there's a folder with a 3 at the beginning in there. There it is. So what you're going to have to do is set your working directory now. So if you go down to, is it manage file? Manage session. Yes, there it is. So if you go into the file menu, go to manage session, and then down near the bottom there, you can select your working directory. So if you click on that, and then browse into that tutorial parts subfolder, and set your working directory for this one into the one that begins with 3. So hand pump sensitivity. And then when you've done that, you can go File, Open, and it will browse into that working directory. So you can see mine's actually looking into that folder that starts with a 3. And within there, there is actually a assembly called hand pump. So that is the one that it's asking you to load in. And that's what it should actually look like. But before we begin that, let's just read a little bit about what we're going to do in this tutorial. So in this one, we're going to use that tool that I talked about at the beginning, which is known as sensitivity analysis. So the sensitivity analysis tool allows you to, as I've written it here, investigate the effects of model changes on monitored or calculated values. So we know now, because we've done that coffee cup kind of prelude, we know that you can monitor certain values within a design, and you can also calculate certain values within a design. We kind of did both of those things in the coffee cup example. We got the system to monitor certain volumes, and then we calculated a new figure from those volumes as well. So that's what sensitivity analysis allows you to do. The system will kind of automatically vary certain dimensions, and you can get a readout in graph form as to how those changes that the system is making is affecting a certain measurement from your part. So what I'm zooming in on here is what's known as a sensitivity plot. So this is initially what we're going to create. And what we're looking at on this particular plot is the volume of, or the calculated volume of water dispensed in each stroke of this pump against the change in length of the link, which is linking the handle to the body of the pump. So you can get a sense of how changing that dimension has an effect on the volume of water pumped. So it's showing you the sensitivity of volume of water pumped to changes in link length. So that's essentially what this tool allows you to do. And that's the first one that we're going to do, changing the link length. So let's get that on a second screen. And as I said at the top, these are directly, or these examples and these models are directly from PTC, who are the people that actually program ProEngineer and Creo. So yeah, all of the analysis features have already been created here. So you can see in the model tree there's certain analysis features. The icon of this range of motion feature is exactly the same icon that we were seeing when we created our volume monitoring features. So you can see very similar setup to what we just did in the cup. Some values are being monitored, other values are being calculated using some of the monitored values as their kind of input for that calculation. So we've got sort of a brief understanding of what's gone on before we open this model up, what was actually being set up before we actually loaded it in. So what is it telling us to do? Model tree filters. So the first thing that we need to do, just as a little bit of housekeeping, is click on this icon here and go into tree filters. Now mine's already set up in the correct way, but yours may not be. So this is kind of for the benefit of anyone that is currently not able to browse inside each part in this assembly. So we're looking at an assembly. The assembly has parts within it, and it also has sub-assemblies within it. And if you can't see this little black arrow at the side of the part icons, it means that you can't browse inside the parts themselves and see the features that make up those parts. And if you can't do that, then the way that you correct it is you go into settings here in model tree, you go to tree filters, and you make sure that features is ticked, because I'll just temporarily untick mine. So untick it and press apply. And it's not for browsing inside the parts, sorry. It's so that you can view those analysis features that were listed up at the assembly level. So you can see my analysis features have disappeared now. So that's just to ensure that you can see them. So click on features, click on OK, and you'll be able to see all these analysis features. So yeah, that's the first check that we need to do. The second thing that we're going to do is we're going to initiate this sensitivity analysis that we're going to do. Again, we're kind of working in the analysis tab most of the time this week. So click on the analysis tab, all the way over towards the right-hand side where it says design study. You can see there's an icon that says sensitivity analysis. And then we drop into this kind of setup window. And broadly what we're going to do here is we're going to give the system the ability to vary a dimension. So that will be this section here. We're going to point at a particular dimension on our design and say to the system, you can vary that dimension between, so we give it a minimum value and a maximum value. And what I want you to do as an output from that is I want you to create me a plot or a graph, if you like, of how changing that value or that dimension affects X. And in this case, affects volume calculated. And that is the volume that's been calculated to be delivered with each stroke of this pump. So that's essentially what we're going to do now. So if we're going to click on dimension first to find the dimension that we're about to allow the system to vary. So click on dimension. Again, the system's waiting for a little piece of input from us, and if we're unsure as to what it's waiting for, we can look down at the bottom left there and it tells us select feature or dimension. So currently there are no dimensions showing on my part. And what I want to allow it to change first is the length of this link. So the easiest way to display some of the dimensions that went into creating that link is just to click on the link itself. And hopefully the dimension that I'm interested in changing will appear. And in this case, it has done, because it's that 8 mil, which is the distance between the two hole centers on that link. So it's that length that I want to allow the system to kind of play around with in this sensitivity analysis. So click on the 8 and it will be collected there. So that's the name of it. It's already been pre-named by the person that set this assembly up. So they've specifically named that dimension length. And again, that colon is identifying where the dimension length is stored. It's stored within a part called link. So that's kind of similar notation to what we were seeing with our parameters that we were bringing into our relations window. They have that little colon in the middle. The first is the specific name of what you've referenced, and then the second reference is to do with where it is stored. So that's that. We want to give it a minimum and maximum that it can vary this between. So we're going to pick 6 mil and 10 mil to allow it to vary this. Obviously, there'll be a sensible maximum and a sensible minimum on any design. So any sensitivity analysis that you run, you have to sort of use a little bit of your logic as a human being looking at the design and say, well, anything past whatever value is going to be pretty much unworkable, and anything under, and then again, you'll have to come up with your own value. But for this example, we've had that decision already made for us. So minimum is going to be 6, maximum is going to be 10. The only thing that we now have to do is tell it what parameter we want graphed on our graph on the actual, I think it's the x-axis, it could be the y-axis. No, it's the y-axis or the vertical leg of the graph. So click on that icon there, and all the assembly level parameters become visible in this window. So again, these are stored at the assembly level. Just like we saw that you can store parameters at the part level or at the feature level, a similar thing happens in an assembly. You can store parameters at the assembly level, which is where all these are stored, or you can store them internally within each part. And then obviously within each part, at a lower level, you have each feature within the part. So there's kind of a hierarchy going on there. And the assembly sits at the top, then the parts, then the features within the parts. So we're viewing the ones at the assembly level here, and it's the calculated volume of volume calculated, which is essentially, again, we know how to read this notation now. There's a parameter that sits inside the feature called volume calc, and that parameter is named volume. So we can kind of understand the notation a little bit more. So click on OK, then click on compute, and we should get a readout as it goes away and kind of varies the model. So essentially what it's doing, it's running different setups of the length of this link in the background, and it's monitoring how they affect the calculated volume that the pump can actually generate. So we're nearly there. I think mine's on 90%. Yeah, there's a little readout at the bottom there. So it's 100% done. Will it give me a little ping when it finishes? I don't think it does. Ah, there you go. So then it says sensitivity calculation completed, and that allows me to kind of get a sense of how varying the length of the link affects the volume dispensed by the pump. And what the PDF tutorials sort of encouraging us to do here is to look at the minimum and maximum value, look at how much we varied the link length by, and try to make some sort of qualitative sort of assessment in assessing, does changing the length of the link largely affect the volume, only slightly affect the volume, or somewhere in the middle? Does it have an average effect on the volume? And it encourages us to interpret that as there's approximately a 7% range in volume there. So the maximum volume is kind of 7% more than the original volume was, which is, I think they assess it as somewhat sensitive. Not overly sensitive to changing the link length, but it does have an effect, but it's a very modest effect. So now what we're going to do is we're going to run the same kind of procedure, but we're going to change the length of the handle this time. So exactly the same setup. So we can kind of shut that one down, and we can close this sensitivity analysis down if we want, and then restart a new sensitivity analysis. But all we get when we restart a new one is the inputs from the previous one are still there. You can see the dimension selected is still the length of the link. So there's very little point shutting it down. You may as well leave the existing one open and then select something new. So I'm going to click on dimension to gather a different dimension this time. And as I've said, it's going to be the length of the handle this time. So I'm going to just click on the handle there, see if the length is one of the dimensions that pops up. It is. So it's that 20 that we want to vary this time. You can see I have actually collected that new parameter or dimension because the readout there has changed. So there's a parameter or a dimension within the handle called length, and it's that one that I've clicked on. And then again, I'm going to give it a maximum and minimum. I think we'll accept the default that the system's just defaulted to. So minimum of 18, maximum of 22. And again, the parameter that we want to plot this against is how much volume of liquid is this pump going to dispense. So we don't need to change this bottom one. So we'll click compute again, and it should go away and do its thing and vary those values and plot them against the volume dispensed. So yeah, it's saying completed. And again, the writers of the tutorial have already calculated that our starting volume dispensed and ending volume dispensed, there's a 10% difference between the two. So again, it's somewhat sensitive to changing the handle length, but not overly so. It's not as if we've been able to double the volume dispensed. It's a modest change. It's in the range of plus or minus 10%. So it's somewhat affected, but and this is kind of how you'd use these sensitivity analyses. You'd be searching for values that yield big changes in a calculated value or a monitored value for very little change in the actual design itself. So we still haven't found one in this instance. So we'll go on and we'll change some other things about this design. So again, I'll shut this graph down. I'll leave the sensitivity analysis open, but this time I'm going to vary the position of that through hole in the handle. So obviously this link would have a pin of some sort attaching it to the handle there. So there's a hole drilled that passes through the actual handle itself, and its position is defined relative to this hole on the end of the handle. And I want to allow the system to now play around with the distance between those two holes. So again, I have to collect a dimension. I don't want to look at the overall length of the handle, so I'm going to click on dimension, and I'm going to zoom in a bit so I can differentiate between the link hole, which is that hole there, and the hole that's actually passing through the handle itself. And when I find the one that's passing through the handle, the little tooltip that pops up there that says F9 hole handle, if it says handle at the end, it's probably the right one, whereas that one says link at the end, so that's not the one that I'm interested in. So it's that one. So you can see the diameter of the holes appeared, but also its distance from this end of the handle, which is currently 7. So it's set at 7. So I want to collect that value by clicking on it. So I've collected the 7. And I'm going to set the range for this one from 5 up to 10. And then again, the parameter that I want to plot hasn't changed, so I don't have to update anything in this parameters to plot box. And then I'm going to click on compute. And I think what we're going to see here is this is the significant dimension. In this design, it is changes in this dimension that yield the biggest sort of change in our monitored value, which is volume of liquid dispensed. So yeah, reading from the tutorial again, the volume increased by approximately 150% of its initial value. So changes in this one are significantly more, or the design, the volume of liquid that the design dispenses is very sensitive to changes in this particular dimension. So our kind of sensitivity analysis has kind of yielded the clear winner, if you like, in terms of dimensions that you're willing to allow change in and how they affect the actual function of the part itself. So that's kind of a sensitivity analysis. So that's what you would use it for. You would use it to kind of search around your design to yield the biggest change in a desired value or a desired measured quantity through modest changes in the actual design of the part itself. So it's looking how sensitive measured value is to change in the part, dimensional change in the part, that is. So let's shut that one down. So that's kind of your feasibility, sensitivity analysis, sorry. And let's move on to the next example, which is something very similar to our coffee cup that we created initially. So you're going to need to shut the hand pump down. And the reason for that is we're going to use the hand pump again in a later example, but this version of the hand pump is slightly different to the later version. So if you don't shut this one down, what will happen is you'll try and load the new version of it up, and the system will bring in parts from this one. So that would be a mistake in this instance. So you're going to have to shut this one down by clicking on that small X at the top there, just kind of by the word annotate. So if you click on the small X, and then I'll probably shut the coffee cup down on my version as well. So I'll shut that down. And then the last step is to erase them from memory, because as I said the other week, Creo still keeps copies of all the parts and the assemblies in memory. And if you don't erase them, it will, again, try and load them straight out of memory rather than loading them off the hard disk. So erase not displayed. It will display everything that it's still keeping in memory there. And then click on OK, and they've all been flushed out of RAM now. And then we're going to move on to the number 4 folder. So we're in the folder name 3, hand pump sensitivity. So we want to go back up one level with our working directory. So back up to tutorial parts, and then down into 4 fuel tank sensitivity. In fact, how are we doing for time? We may skip this one and revisit it towards the end, because this is just another example of how to use the sensitivity tool. But in this case, we're looking at something very similar to our coffee cup. So it's a fuel tank. It's created using a shell command. The technique that's then been set up for us to calculate the internal volume is exactly the same technique that we used on the coffee cup. You take the unshelled volume and then you minus the shelled volume from it. But all of that work has already been done. It's just setting up a sensitivity analysis to see how changing the length of the tank affects the amount of liquid that it can hold. So I think, yeah, we'll skip that one because we kind of covered that on the pump that we just did. So I'm keen to get a good mix of different kind of analyses. I think what we'll do is we'll go backwards. We'll go to number 6 here, because that's a significantly different sort of setup Or can we do that? No, let's go to 5. Sorry, I'm thinking on the fly here. I'm very aware that we often run out of time, and with this session in the past, we have run out of time. So I want to get as much as possible in. So let's go number 5, hand pump optimization. We're going to use a similar looking hand pump model. So I'm going to go to open in subfolder 5 there, load the hand pump back in again. It looks identical, but there are subtle differences that have changed in here. So it's worth flushing the other one out of memory and bringing this one in instead. And then I'll get the PDF open on my screen as well. So now we're optimizing the hand pump. So we're going to do an optimization analysis. And again, just to recap, this sort of gist of optimization versus sensitivity. So sensitivity was just a very sort of simple tool for kind of doing little simple experiments on your model in a very sort of manual way. So you would apply it to a dimension and see how changing that dimension affected some measured value. The optimization that we're going to run now does something similar, but you can give the system direct access to multiple dimensions within your model, and you can give it a specific goal that it's trying to work towards. And then you can give it specific rules that it cannot break. So in this particular setup, what we're going to do is we're going to give the system access to certain key dimensions. So maybe the length of the link, maybe the position of that hole, maybe the length of the handle. And then we're going to give it an overall goal of increase the volume pumped by this pump to its maximum possible. So we've got a driving goal. We've got some dimensions that we'll put limits on it, their maximum and minimum that it's allowed to vary them by. And then just as a final little kind of rule, we'll give it a rule which says the underside of that face there cannot get nearer than a quarter of a millimeter to that face there. So there's a clearance kind of constraint that's been enforced. So all the sort of investigation that the system's going to do of the values that we give it, it will keep an eye on whether that constraint ever gets violated. So do those two faces ever get nearer than a quarter of a mil within each other? So that's kind of an optimization study. It has a goal. You're trying to achieve something specific. And when I say you, I mean Creo will go away and automatically achieve that in the best way possible. You just do the setup of it. So let's get going with that. So it's in analysis. Again, it's a type of analysis and optimization analysis. And it's the next icon down underneath sensitivity study. So feasibility and optimization. You want to make sure you've got optimization selected because there's two subtypes in here. There's one that's known as a feasibility study and one that's known as an optimization. It's optimization that we're using in this case. Now, the first thing that we're going to set is this overall goal. What is the goal of this optimization? What are we trying to achieve? And these tend to be stated as minimize, maximize, or minimize to a specific value. So yeah, it's less about a yes/no question, and it's more about make something as small as possible or make something as large as possible within the design constraints that we're about to give it. So what we want to do is we want to maximize the volume. So the monitored value that has been named volume, which is stored within an analysis feature called volume calc, that is what we're looking to maximize through our changes of certain dimensions that we're going to enter into this next box. So the dimensions that we're going to allow it to vary, we click on add, and then if we click on the link, Ah, that's interesting. Sorry, I'm going backwards here. I was having a little moment there. Sorry, we're working down from the top to the bottom. I was thinking I was in the box lower down, which is where you give it access to its to the model dimensions. So, design constraints section. This is the section where we define certain hard rules for this analysis. And the one that I talked about before we came in was that the clearance between the underside of that component there and the top side of that component there cannot get closer to each other than a certain specified value. So this is what we're about to add here. So this is a constraint. So we click on add. Again, there's been values set up already that are monitoring these specific quantities that we are now using. But we're kind of aware that we could do that if we wanted to. It's just that on this model, they've already been set up for us. So we've got a little drop-down list here. And it's that one. It's a calculated clearance between two components. So it's clearance at a feature or inside a feature called clearance. So that's the one that we want to reference. And we want it to be greater than or equal to. So we're going to pick the bottom option there. Greater than or equal to. And then we want to be able to enter a value in here. So we've got to click from current to set. And we're going to set it as 0.25. And then click on OK. And that will be entered there. And you can put multiple design constraints in. It's just that the more sort of inputs that you enter into this setup box, the slower the calculation is going to be. So the slower the analysis is going to be. And that goes for the dimensions that we're about to add as well. So if you give it, say, 10 dimensions that it can play with on your design, it will take it a significant amount of time to calculate the optimization study. So bear that in mind. It's good to use this tool. It's automated. It takes a lot of the work away from you having to manually change things and do analyses. But if you stack up multiple dimensions in here, you can increase the calculation time massively. So what dimensions are we going to give it access to? So we'll start adding them. We'll add a dimension. The first one that we're going to give it access to is the length of the link component. So I'm just going to click on the link. And it's the length value. So it's that one that is currently set to 8. So it collects that. We'll keep going. We'll add them all in first, and then we'll set their minimum and maximum after we've collected all the dimensions that we're going to allow it to change. So the next one is going to be part of the handle, and it's going to be the length. So it's that one that's currently 20. So we'll collect that one. So it's everything that we kind of looked at previously. The next one is going to be the position of that cross hole through the handle. So it's just those 3 that we were looking at when we were doing the sensitivity analysis. So that hole, which is contained within the handle itself. So you'll see the pop-up saying handle at the end. And it's its distance from the end, which is that 7 currently. Then we'll set the minimum and maximum values that we want to allow it to vary. And again, these have knock-on effects in terms of the length of calculation time. If you go for very narrow ranges, the calculation will be very quick. And if you go for very wide ranges of values, it will slow that calculation time down because the system's going to have to go away and investigate far more variations of the design the larger the range is. So let's change these to what it's suggesting. So that's what we need them set to. So I'll leave that on the screen for a second. And at that point, we're kind of ready to run the analysis. So I'll just check that we've not missed anything out. Yep, we'll just do a compute. So when we get to that point, we can hit compute, and hopefully it won't take too long. I think mine was taking a while earlier, but we'll see how long it takes. So if you can imagine what it's doing in the background now, it's varying those three values, those three dimensions, between those upper and lower, or minimum and maximum values. But what we haven't specified there is the jumps or steps between, let's say, 6 as a minimum and 10 as a maximum. So what it's trying to do is it's trying to vary the step sizes that it's varying between minimum and maximum. So let's say initially it might do a very coarse pass, and it might only have three values between its minimum of 6 and its maximum of 10. But then it's trying to see any trends that occur within that range, and then it might go back in and further investigate uh, certain areas within that range in a much finer step size. So it might then minimize its step size down to, say, 1 mil difference. So it's trying to look for trends within the ranges that it's been assigned. So it can take quite a while. I think mine's on step 3, and it generally gets to a fully optimized design by step 10. If anyone else completes earlier than mine, if you've got a better, more modern processor, or maybe more memory, yours might actually complete before mine actually gets there. But we'll sit and wait for it. So that's kind of an optimization study. We'll talk a little bit about feasibility studies because they're very closely related, these two, which is why they're available from the same menu. So if you want to think as the optimization study as the fully featured one, and then a feasibility study is kind of a cut down version of an optimization. And the reason I say that is a feasibility study doesn't have really a goal as such. It's not trying to maximize or minimize anything. It's kind of a yes/no question. Can X, Y, or Z be achieved? Is the question that you ask the system. And the tool that you give it to achieve whatever you've set it to achieve is the ability to vary dimensions. So the setup is very similar to this, but there's not an overall goal, as in you're not looking to minimize anything, you're not looking to maximize anything. You're just asking it a question. Can this value be made equal to something? Or can this value be made less than something? And it will come back with either a yes answer or a no answer. And if it's a yes answer, it will offer to change your design to the version which satisfies that yes/no question. But the two are very similar. Feasibility, as I say, you can almost regard it as a slightly cut down version of a full optimization study. But hopefully we're going to have time to have a look at that as well. I think we've got just over 30 minutes left, so we should be good to have a look at that. Still only on step 4 here. If anyone's completes, just shout in the chat that yours is actually finished. But essentially all we're waiting for is it to tell us it's finished. And then the final screen here will say, do you want to keep the changes that I have just made to your design? Or do you want to revert the design back to as it was before you ran the study? And that's essentially the final step. So that's what you're looking for. Either the fully optimized design and you accept the changes, or jump back to where you started for whatever reason and maybe run a different optimization. So yeah, we're only halfway through. I suspect if you're all having similar experiences to me and yours are running quite slow, so what it can be useful to do is have a look at the Windows Task Manager and see how much of each processor it's actually using. So mine isn't using a huge amount. So it's sort of bouncing along there at 30 something percent usage. So it's not terribly overloading the CPU. So I suspect I could probably drop back into my installation of Creo, and I think there's a parallel processing option that you can tick as you're installing it that is off by default. And I think that is possibly the issue at the moment. So it's not fully utilizing my multi-core kind of CPU, which is why it's quite slow. But we are on step 9 now, so it should be nearly finished. I believe it takes 10 steps to actually complete this optimization. Yeah, other people are saying theirs is slow as well. If people are running it on the virtual desktop, I'm surprised that that one isn't going really quick, because the machines that those virtual desktops are running on, I think, are quite quick. So maybe it's here we go. Anyway, so optimization is finished, fully optimized. What we didn't kind of pay attention to there, and that was kind of my fault, although hopefully you can kind of see it now, is it has actually changed the model in the background. So you can probably see that link was much shorter when we began. I think that link was only 7 mil long, or whatever these units are. I think we're working in inches on these designs. But yeah, it's increased the length of that. It's increased the length of the cross drill on the handle to accommodate the length of that link as well. So it's made the changes that provide the maximum volume with each stroke. So all we have to do now is, as we shut this optimization study down, so as I shut this window that says optimization feasibility, so I click on close at the bottom, I get this little readout just saying, do you want to confirm these changes? Do you want to keep them as they are now, fully optimized? Or for whatever reason, do you want to restore the original dimensions of your model? So those are your two options. But given that we stated that this is what we're looking to achieve with our design, maximize the volume within these ranges of values, you will probably click on confirm and just keep that design. Unfortunately, you can't then undo there. So the undo option disappears. So what I would suggest, if you're trying to optimize your designs, maybe take a save of it before you run the optimization. So that if you then change your mind here and think, hang on a minute, I want to actually return to the original, I don't want this version, then you can then load it back in off the hard disk. Maybe even save it under a different name. It's always good to have sort of backup copies so you can undo things that aren't available with the undo button at the top of the screen. So yeah, that's essentially optimization. So we kind of covered the setup of analysis features. We kind of understand a little bit about that, how you would monitor certain values, volumes or distances or those sorts of values, how you would use your sensitivity analysis tools to kind of probe the design slightly and kind of see how sensitive certain measured values are to change in your design. So that's your sensitivity. How you'd go kind of fully automated and let Creo do the optimization itself. So that's kind of what we've just done. We set up an optimization study to let Creo do the kind of hard work for us and achieve some kind of goal. And then the final bit that we need to do, just to kind of experience all these tools, is the feasibility study. So I think we'll drop in and do that now. And then if we've got any time left, we may double back and do the fuel tank sensitivity analysis as well. So let's shut the pump down. You've seen mine complete there. So if yours is still running, I believe there's a little red X icon somewhere around the bottom of the screen. Let me just start mine running again so I can confirm that. There it is. There's a little X in white surrounded by a hexagon in red. And if you click on that, it should try and abort your optimization study. And you can always drop back into that later on. Obviously, we're recording these sessions So if you need to, you can kind of revisit that and have a bit more time to let it actually complete its analysis. But ultimately, we've got to move on. So I'm going to shut that part down because we don't need that part. We're not going to use the hand pump again as an example. So click on the X at the top to get rid of it. I'll probably erase it from memory just because I get into that habit because it's a good thing to do most of the time. So erase not displayed. And then I want to set my working directory this time to the bottom option there, number 6. And within this folder, so I've just gone to open a new file out of that new working directory. There is only a single part file. That's all there is in there. And this is the crankshaft that I was talking about earlier. So this tutorial is kind of a combination of all the other skills that we've either done or are included in the other tutorials. So there's the skill of creating analysis features ourselves and naming them and kind of providing values and what have you. And then there's a little bit of sensitivity analysis initially, and then there's a feasibility study as well, and then eventually we move on to an optimization study. But ultimately, and the PDF kind of says the same thing, the PDF for this number 6. Our ultimate goal is to do with this crankshaft. If I can just get this PDF open on the other screen. Yep, there it is. So our ultimate goal is to do something to the design of this crankshaft. And the center of gravity is not aligned with that center axis. So I'm assuming you all know a crankshaft spins round a certain center axis. I've just clicked on it in green there. It runs down the sort of central shaft of this design. So there's bearings on these shafts that are kind of holding all this in place, and it spins, and you'll have some form of rod attached here, conrod. And the general goal is that the center of gravity should be coincident with that center axis that it's spinning round, because otherwise it's going to kind of it's going to wobble, for want of a better word. So what we're going to do initially is we're going to create an analysis feature or a pair of analysis features to ascertain how far away from that spinning axis, that center axis, the center of gravity is currently. So that's the first thing that we need to do. And the way that we're going to achieve that is we're going to go into analysis. We're going to go to the measure drop-down menu. And the thing, or are we? I may have gone wrong already. No, we're not. The thing that we're interested in is identifying where that center of gravity is currently. And as far as Creo is concerned, the center of gravity is a sort of byproduct of the mass of the part itself. So it's included in the mass properties. So if you click on mass properties, amongst other data, you actually get, so you get things related to mass, but only tenuously. You get things like the volume of the part. So I clicked on preview there. So I opened up this new window by clicking on mass properties. It initially was empty. When I clicked on preview, it gave me a preview of some of the data that is available to me when I create my mass properties feature. So things like the density of the part, which I haven't set in this instance. I haven't told the system what material this part is made out of. The mass is obviously included within the mass properties, but then other things like the center of gravity in X, Y, and Z, where it's located currently. And if I just move my view around a bit, there it is. That is the center of gravity, that coordinate system. And it's plainly what I'd consider below the rotational axis of this crankshaft. So currently, there's too much weight in these lobe sections, if you want to think about it like that. They weigh too much. They account for too much of the volume of the overall volume of the part. So something's got to be done about that. But the first step is to create a feature using our mass properties tool here that places a point in space that we can click on, and then we can get a measurement as to how far away from the center axis line that point is. So that's what I'm trying to achieve right now. So I want to create a feature just like I did with the volume measurement. So I'm going to click on the feature tab. Perhaps I'm not going to click on the feature tab. No, sorry, I went wrong there. There's a drop down at the bottom that says quick, saved, or feature. So quick is what we've just done. It allows you to quickly get this window open, click on preview, and manually just read some of these values. So it's just a good tool if you just want to quickly drop in and say, oh, I wonder what the overall mass is. Oh, right, there it is. Brilliant. Right, I'll close that down now. So that's the intention of that. Saved is sort of a halfway house. It doesn't create a true feature, but it does kind of save this number. And then feature does similar to what we did when we created a volume feature. It creates a new feature in the model tree, and within that feature there are certain parameters that can be saved. And one of the parameters is the location of the center of gravity. So feature is the one that we want. And the tutorial's suggesting that we call this mass properties. So I'll get rid of the 1 off the end of it. So mass props, I think it's suggesting. And within the feature, the parameters that we require, we're about to define now. So in the feature tab at the top there, in our mass properties window, click on it, and you can see there's a list of potential parameters that can be monitored within this feature. Now, the mass we're not interested in, surface area we're not interested in, volume we're not interested in, any of these others of no interest to us. What we are interested in is having a point in space at the center of mass, or the center of gravity, to use more common sort of parlance. So I want to tick that one. And that's kind of all I want in this particular analysis feature. Just a point at the center of gravity. And I think just to show that we can, we'll edit the name of that point or that feature to just COG, or center of gravity. And then we'll click on OK. And rather than being a numerical parameter that we've stored within this mass properties feature that's now appeared, the only thing that's stored within there is that point that's now appeared in space. So that point is a sort of child of that feature. It's created by that feature. It lives within that feature. But it isn't kind of a numerical value. It's an actual point in space that's been stored in there. So what we've achieved there is we now have 2 clickable items or selectable items in our graphics window that we can create a distance feature between. So we can monitor the distance between those 2 items now. Before, we didn't have a point in space that we could select to get a distance between the rotational axis and where the center of gravity currently is. But now we do. So that's the first step. So we're going to create a distance measurement. So we're in the analysis tab again. We're in the measurement drop-down box this time, just like when we did the volume measurements. It's a distance between 2 items that we're going to click on. So I'm going to click on the center axis first. Hold down Control, like we have to in lots of features when we want to pick multiple things. So hold Control. Click on the center of gravity point. It gives me a nice little annotation telling me what it currently is. So it's about 1.6 mil between them at the moment. And then again, what I'm going to want to do, so that's all well and good, that's good information, but as soon as I shut this window down, that disappears. So what I want to do is I want to create a feature that stays resident in the model tree to monitor this value. And we've been in this kind of measurement tool before, and the way that you create them in here is click on that disk icon, make feature, and we'll give it a specific name. So we'll give it a name which is COG for center of gravity distance. So that's the distance of the center of gravity away from the rotational axis. So that's what we're going to call the feature. Click on OK. It should pop up in the feature tree. It does. And then I don't know whether you'll be getting this, although I've got it on my screen. So I have an extra column here in the model tree that I've specifically made visible that allows me, the user, to just view what that monitored value currently is. So I'm pretty sure you won't be able to see that. So I'm going to switch mine off and show you how you would do something like that. So mine's disappeared now. Whether that came through with the saved files, maybe you were looking at it anyway, but it's not a standard column that you would normally get in your model tree. But what I know is that within that feature called COG distance, there's a parameter that's just called distance. So there's a parameter in there, its name is distance, and it lives inside the feature called COG distance. So what I can do, knowing that, is go up here to the kind of setup of my model tree, how my model tree appears. Go into, which one is it? Tree columns, because it's a new column that I want to add down here. And then it's not a standard sort of clickable thing here. I just have to remember that it's called distance. So what I'm going to do is I'm going to say it's a feature parameter that I'm looking for, because I know it's stored inside that feature. So it's a parameter that's stored inside a feature. So I'm going to click on feature param, and then I know, just because I've remembered, it's called distance. So I just type distance. And then any features that have a parameter within them called distance will display what that value is in a new column here. So when I type distance, click on that icon, that kind of double sideways arrow, and it will add it into the model tree. And then click on OK, and you end up with a new column. And seeing as I only have one feature that has a parameter within it called distance, I only get that single value there. Yeah, I can repeat that bit. Just give me a sec. I'll get rid of that tree column. Like that. So that's the standard readout. And if I want to add any more columns to the model tree, because currently I've just got the default column just showing me the feature names and feature icons, it's that sort of hammer and screwdriver looking icon at the top for settings. Tree columns to add more columns in or edit the existing columns. And then again, I'm going into this with a little bit of pre-existing knowledge, and the pre-existing knowledge that I have is that there's a feature in this model tree that has a parameter within it called distance. So what I want to do is say the type of info or the type of tree column that I want to add is a feature parameter. So I knew that already, because I know there's a feature called COG distance, and I know that there's a parameter in it called distance. So it's a feature parameter. That's where I'm going to pull this information from. And then it just requires a name for the parameter itself. So again, I know it's called distance. So I'm just going to type distance. And then if any of these features have a parameter within them that is called distance, it will get displayed in this new column that's about to appear in my model tree. So when I've typed in the parameter name that I want, I just have to click on that double arrow, which adds that column into the columns that are displayed in the model tree. So click on that arrow. It jumps across onto the right-hand side there. I can play around with the width of it if I want to. you could see when that was displayed, it had numerous decimal places. So maybe I would want a wider column, but I could do that maybe if I needed to. And then you can, if you want to preview it before you exit this menu, you can click on apply and it will show you what it's going to look like. So now I've decided it's a little bit too wide. Maybe I'll bring the width of it down and press apply again. Yeah, you get the idea. Maybe bring the width down to 5 and then click on OK. So there I can monitor visually that value now. Obviously the system has access to it anyway, but visually as the user of the CAD system, I can actually just monitor it by just glancing down there as well. So we kind of done that. We put our 2 analysis features in, and one of them is kind of a sort of calculation from the first one. So you need that center of gravity point in order to create that distance measurement. So let's keep going. Right. So the next bit in this tutorial that I'm going to skip over is just more of the sensitivity analysis that we did right back at the start. It's just using the shape of the lobe, which is, where is it? It's there. So in the model tree, there's a hidden sketch named lobe, which if you click on it, you can see the shape of that sketch. That's kind of the governing shape of this kind of counterbalanced lobe section of the design. So if you wanted to change anything fundamentally about that lobe shape or its size, that would be the sketch that you would make the change in. And if I wanted to change that, I could just click on it there, click on that D1 icon that pops up, and you can see all the governing dimensions that actually govern its size and shape. So the thought is here, you would run a few sensitivity analyses, which are the ones where you can see the effect of varying dimensions and how it affects a measured value. So I think it suggests that you let the system modify this one and see how that affects the distance that we're monitoring. And then you let the system modify the thickness of these lobes. So there's an extrude, which governs the thickness of the lobes themselves. If I can make that visible. Yeah, that's not it. Yeah, you get the idea. Using the sensitivity tools, what I'm keen to do is use the feasibility analysis because that's the one thing that we haven't done yet. So I'm going to skip forward to the part in the tutorial where we use the feasibility analysis. And here it is. So here's the page. Task 4. Perform a feasibility design study to determine whether the center of gravity can be moved so it is in line with the rotational axis. So this is that sort of yes-no question style of analysis. It's not an optimization. We're not looking to minimize or maximize anything. We're just asking a simple question. Can this distance be made to be 0? That's essentially all we're asking. So that's what we're going to set up now, because that's kind of the one skill that we haven't covered yet in any of these. So I'm in the analysis tab. I'm going to click on feasibility optimization because, as I've already said, they're kind of one and the same. Feasibility is kind of just a cut down version of optimization. And when I click on feasibility, you can see exactly what I was describing earlier happens. So the overall goal of the study disappears because you do not have an overall goal. You just have a constraint. You're just asking a simple question. Can this be achieved? Yes or no? And that's it. You're not looking to drive something to its absolute minimum or maximum. So add a constraint, distance, COG distance. So this is the distance parameter that we have created that is stored within the feature, which is named COG distance. So there's a feature called COG distance. Within it, there is a value or a parameter called distance. That's what we want to look at. And what we're asking is, can it be made equal to, and then we want to set a value of 0. So that's sort of mathematical way of asking the system, can you, through any change that we're going to allow you to make, get the center of gravity coincident with the rotational axis, so that as this thing spins round its rotational axis, it doesn't wobble, essentially. So that's what we're asking. So click on OK. That's our design constraint. All we have to do now is supply it with some dimensions that we're going to allow it to vary in pursuit of that sort of design constraint. So I'm going to add a dimension. And the one that I'm going to let it change is the lobe. So if I click on the lobe sketch, which is hidden currently in the model tree, so the sketch which is just named lobe, and it is that 25 value. So that kind of scale of that lower section of this lobe is what I'm going to allow it to change. And I'm going to give it a range that it suggests in the tutorial. So minimum of 21, maximum of 24. So it's quite a tight range. And then the last little bit here is ensure you graph the variables and constraints. So in order to do that, we have to be able to click out of these entry boxes. And I've not found a good way to allow you to do that up to this point, other than this one, which seems a little bit backwards. Temporarily switch it to an optimization and then quickly switch it back to a feasibility study. And then you can click on the options menu at the top. So I'm not quite sure what I'm missing there, if anything. Maybe it's just a corruption of the Creo install. But if you temporarily switch it to an optimization, switch it back to a feasibility study, you get to be able to click on this options menu at the top. And in preferences, amongst other things, I can change the readouts or the graphs that I create. What do I want graphed? And it's the variables. I want to see what this dimension gets changed to at certain points along this feasibility study. And I also want to graph the constraints. So you want everything ticked in there where it says graph. And then hit compute. And it appears as if we've only got one graph there. But if you drag that out of the way, you'll see that there's another one behind it. A feasible solution has been successfully found, is what it's telling me. And what are the graphs looking like? So for some reason it's not labeling this axis, which I find a bit odd. So what are we looking at? We're looking at this axis here is the dimension that I've given it access to change. So you can kind of surmise that. Quickly clicked on the graphs and they've disappeared. So there they are. You can surmise that that is because the range that I gave it to play with ended at 24, if you remember. So the range of values that I allowed it to play with. So it's come down to kind of somewhere between 22 and 22.2. So let's call it 22.1. So it's modified that value to 22.1, and then it's decided that the distance that it's also monitoring that started off up here has actually tended towards 0 now. So that's why we needed to have this graph as well, because we needed to be aware of what change it had made to the model or to the dimension that we'd given it access to in order to achieve its stated kind of design constraints that we were asking it to achieve. And then at the readout at the bottom, it says a feasible solution has been successfully found. So it's kind of answered our question. Our question was, is it possible in this range of values to make the distance between the center of gravity and that axis 0? And the answer is yes, it is possible. And then if we were to close out of there, again, it would ask us a similar question than it did when we were running the optimization. It will basically say, I have made a change to your model to satisfy this design constraint. Do you want to keep that change? Or do you want to reset your model back to as it was before you ran this feasibility study? And obviously, you could pick whichever one you needed there. But the ultimate goal of this bit of the tutorial, or this tutorial, is to eventually run an optimization on this thing again. So the recommendation here is it's saying click on undo to undo any changes that the feasibility study made, because ultimately you're going to run a full optimization study on it. So those changes may be kind of overwritten, so you don't need to keep them. But if you were just looking to achieve that, and you weren't looking to achieve any sort of goal as in tandem with it, you could just click on confirm. But I think in our case, we'll click on reset and watch the model go back to as it was before. So you saw those lobes actually grow and go back to their original kind of size. So I think we'll leave that there. You kind of got the kind of intro to how to use those different types of tools. So we've had a look at what the sensitivity analysis allows you to do. We had a look at the optimization study, the feasibility study, and kind of underpinning all that is this ability to create kind of measurement tools. And the term that it uses in these tutorials for these measurement features, I'm trying to find where it refers to them. It refers to them as BMX, which may seem a bit of an odd term to use when you're talking about these features. I'm trying to find some mention of it to prove that I've not just totally imagined this. But essentially, the BMX acronym in this case is Behavioral Modeling Extension, which is a plugin for Creo, which is the plugin that you don't get with the student version, but you do get it with the university versions. So when it talks about BMX features, it's behavioral modeling extension features. And that kind of covers all these volume monitoring features that we've created, all the distance monitoring features, all the mass properties features, and all their parameters that you can also store within them as well. So those kind of three skills, being able to create those features, those BMX features, as they used to be called, being able to store parameters in them that monitor a particular value, and then referencing those values in our kind of optimizations or feasibility studies. It's kind of the whole package of analysis tools, essentially. So yeah, I think we'll leave it there. I'll upload the recording, so if you need to drop back into any of this, you can. And as I said, there's pretty good detail in the PDFs that we have kind of worked through this week anyway. So you can always kind of drop back into them. And more than that, if you go to the link, the YouTube link that I've left up on the tutorials page, you can probably spot some of the tutorials in there that we've been doing this week. So even if you don't watch back the recording of this week's session, you can see I've already been in there on previous years, and I've kind of uploaded. There's the hand pump sensitivity. There's a thing that is an alternative to the coffee cup one where you just monitor the volume of a sphere. There's the one that we didn't get to do, which is the fuel tank. Yeah, there's the full version of the crankshaft one there as well. So it's all there. You can dip back into it as you need to. So yeah, I think I'll sign off for this week, and I'll see you again next week. And we'll move on to the next kind of topic.